In this video, I will cover lesson 13-4, volumes of right pyramids. This is the key concept.
The volume of a pyramid is the number of unit cubes needed to fill the pyramid. The formula for the volume of a pyramid is 1/3 the product of the base area and the height of the pyramid.
All right, this little video will explain why this formula works for volume of a pyramid.
Suppose you have a pyramid and a prism with the same base and the same height. By turning these solid figures into containers, you can show a relationship between their volumes. Find out how many containers of the pyramid it takes to fill the prism. It takes 3 containers of the pyramid to fill the prism. So the volume of the prism is 3 times the volume of the pyramid. This means that the volume of the pyramid is 1/3 the volume of the prism. Remember that the volume of a prism equals the area of the base times the height. So the volume of a pyramid, V, equals 1/3 B times H.
All right, you can go ahead and write this under words. Volume of a pyramid is 1/3 area of the base times the height. You can add the words height of the pyramid in this case, and go ahead and write this under the variable form of the formula. Volume equals 1/3 capital B times H. Remember, capital B means the area of the base, and in this case, H means the height of the pyramid, since we're finding volume of a pyramid. Part 1 example.
What is the volume of each square pyramid? Place them in order from least volume to greatest volume.
All right, I'm going to go ahead and label these just to make it a little easier when we're solving. I'm going to find A first, the volume of A. I'm going to first start by finding the area of the base. So that's capital B. And let's look at the base for A. The base of A is a square. So we're going to use side length square. And then we're going to go ahead and substitute in 10 for the side length, and we have to square that. So the area of the base will be 100 inches squared. Now we're going to go ahead and find the volume of pyramid A. So volume equals 1/3 area of the base times the height of the pyramid. Remember, capital B times H, that was the formula we learned for volume of a prism. And all we have to do is get 1/3 the volume of a prism to get the volume of a pyramid. Now I'm going to go ahead and substitute the information in. We found out the area of the base was 100, and then the height of the pyramid, you just go from the point straight down, and we find out that that is 9 inches. Now you can multiply this however you want to, but I think it's easiest to get 1/3 of the height, and that will end up being 3. And then you multiply that by 100, and 3 times 100 is 300. And don't forget your units. So this was inches square, and this was inches. Now we do inches squared times inches, that will be inches cubed. Remember, volume is always cubed. So A, the volume for A will be 300 inches cubed. Now I'm going to go ahead and find the area of the base for B. That is also a square, so we're going to use side length square for the area of the base. The side length is 9, and we're going to go ahead and square that, which is equal to 81. Don't forget your units. That will be inches squared. Now we have to go ahead and find the volume. The volume formula is volume equals 1/3 area of the base times the height of the pyramid. Then you go ahead and substitute in everything. We found out that 81 inches squared was the area of the base, and then the height, remember, is from the peak all the way straight down, and we found out that that was 13. Now we can multiply this however you want to, but I'm going to get 1/3 of 81, which is equal to 27. And then multiply that by 13 inches. And we end up with 351, and that will be inches cubed. So B, the volume for B will be 351 inches cubed. Now I'm going to go ahead and find the volume for C. We're going to first find the area of the base, and the shape of the base is a square, so we're going to use side length squared. And the side length will be 7. And if we go ahead and square 7, that will be 49. Don't forget your units, that's inches squared. Now we're going to use our volume formula, which is volume equals 1/3 area of the base times the height of the pyramid. Then you go ahead and substitute in all of your information. Here is our area of the base, which is 49. And then the height from the peak all the way down, that would end up being 15. You can multiply this however you want to, but I'm going to go ahead and get 1/3 of 15, which is 5. And then 5 times 49 is 245. And don't forget your units, that's inches cubed. Volume is always cubed. Now, if we were to label this from least to greatest, the least will be C, 245 inches cubed. Then the greatest will be B, 351 inches cubed. And the middle will be A, 300 inches cubed. Part 1, got it.
Ms. Adventure visited Mayan pyramids in Mexico. The structure shown approximates a square pyramid with a base side length of 55 meters and a height of 30 meters. What is the approximate volume of the pyramid?
Remember, first you can find the area of the base, and then you will substitute that into the volume of a pyramid formula. B is the correct answer. Don't forget to have your units cubed. Here is the solution. Step 1, you have to find the area of the base. You use the formula of side length squared since the base is a square. And we find out that this is the area of the base. Now you're going to go ahead and use your volume of a pyramid formula. We found out we needed to substitute this number in for the area of the base. The height of the pyramid was 30. You can go ahead and get 1/3 of 30, which is 10. And then you will multiply 10 times 3,025, which is this number here. And don't forget your units. Part 1, got it, 2 of 2.
What happens to the volume of a square pyramid when you double the side length of the base?
All right, here's an example to help you figure out this problem. We will use the same volume formula. Volume equals 1/3 area of the base times the height of the pyramid. Let's say we had the base, the side length for the base to be 3. We found out that the volume would be 12. Now, if we double that, and instead of using 3 for the side length, we use 6, then let's look here. The volume will be 48. Notice the heights are still the same. We're not changing the heights. We're just doubling the side length. So here, the volume of these pyramids are 12 meters cubed and 48 meters cubed. When you double the side length of the base, the volume of a square pyramid quadruples. Part 2, example.
Miss Adventure's tea package has the shape of a regular triangular pyramid. To the nearest tenth of a cubic inch, how much tea can the package hold?
That box is made out of cardboard, but we want to know the amount of tea that fits inside it. So we need to know the amount of space inside the box. It looks like one measurement here is more useful than another. See, all this keeps going back to the essential question. Interesting.
All right, this particular question does not say, oh, we need to find the surface area or we need to find the volume. It gives us little things that we need to read. It said Misadventure's tea packet has the shape of a regular triangular pyramid. To the nearest tenth of a cubic inch, that's our first key, cubic inch. We know volume is to the cubic inch. And it also says how much tea can the package hold. So how much tea can the package hold? We're trying to see how much can fit inside of it, which is also the volume. So we're going to go ahead and find the area of the base first. First, we're going to identify the base. That's this here. Now we're going to write our formula. So the base is a triangle. The formula for area of a triangle is 1/2 base times height. Now we're going to substitute in the information. What is the base of the base? So if we're looking at this triangle, just this triangle here, what is the base of that triangle? Well, the base of that triangle is 1 4/10. Now looking at just that triangle that I outlined in pink, what is the height of that triangle? Well, the height of that triangle is 1 2/10. Now we can go ahead and multiply all of this together. It doesn't matter which order you want to multiply it in. I'm going to go ahead and get half of 1 4/10, which is 7/10. And then I'm going to multiply that by 1 2/10. And I end up with 84 hundredths, and that's inches squared. So that would be the area of the base. Now I have to use my volume formula for a pyramid. Volume equals 1/3 area of the base times the height of the pyramid. Now you're going to substitute in your information. We found out the area of the base is 84 hundredths, and that's inches squared. And now the height of the pyramid. So from the very top all the way straight down to the bottom, to the base, that will be 3. Now you can multiply this however you want to. I'm going to go ahead and get 1/3 of 3. So I'm going to do 84 hundredths inches squared. And 1/3 of 3, that is just equal to 1 inch. So if I multiply all of that together, I get 84 hundredths inches cubed. But it told us to round. If we look here, it says to the nearest tenth. Right there, to the nearest tenth. That means one place value after the decimal. So that means right here. And that will round to 8/8 inches cubed. Part 2, got it.
To the nearest cubic foot, what is the volume of the regular triangular pyramid?
All right, first you need to figure out what the base is. So you can use this one at the bottom as your base. Find the area of that, and then you're going to find the volume of the entire pyramid. The correct answer is B, 119 feet cubed. And here's your solution. Step 1, find the area of the base. So we know it's a triangle. You use 1/2 base times height. The base of the triangle, so if you look at the bottom, the base of that triangle is 10. And then the height of that triangle that I outlined in blue is 8 7/10. And then you go ahead and multiply all of that. This is the area of the base. Now we have to use the volume formula. You're going to substitute in this number for area of the base. The height of the pyramid, remember the height of the pyramid goes from the very top straight down to the bottom. So that is the height of the pyramid. And then you have to multiply all of that together. You get 118 9/10 feet cubed. But you have to round, and we end up with 119 feet cubed. Part 3, example.
Misadventure's tent has the shape of a regular hexagonal pyramid. To the nearest cubic foot, how much space is in the tent?
Which is bigger, a tent that's 3 feet on a side or one that's 3.5 feet on a side? You can't be sure unless you also take the tent's height into account. Finding the volume lets you do that. Looks like I'll need a lot of volume in my tent. Here we go. Wide load. Everybody move out the way.
First thing I'm going to do is find the area of the base. And the shape of this base is a hexagon. So let's remember the formula for area of a hexagon. We know we can decompose a hexagon into 6 equilateral triangles. So if we find the area of one triangle, which is 1/2 base times height, all we have to do is multiply that by 6, and that will give us the area of this entire hexagon. Now, I'm going to focus on just this one triangle here. We have to figure out the base of that one triangle. Well, the base of that one triangle, I'm going to bring down all of this information. The base of the base, or the base of this one triangle, is 3 5/10. Because if we look here, the side length of the hexagon is 3 5/10. That means all sides of the hexagon is 3 5/10. Now the height of that triangle that I outlined in blue will be 3. Now I'm going to go ahead and multiply all of that information. It doesn't matter how you multiply it. I'm going to get 1/2 of 6, which is 3, and then 3 5/10 times 3. Now I'm going to do 3 times 3, which is equal to 9, and then 9 times 3 5/10 would equal 31 5/10. And don't forget your units, that will be feet squared. So the area of the base, or the area of that hexagon, is 31 5/10 feet squared. Now I have to find the volume. Volume equals 1/3 area of the base times the height of the pyramid. Substitute in 31 5/10 for the area of the base. The height of the pyramid is from the very top straight down to the bottom, which is 4 7/10. And then you can multiply this however you want to. I'm going to go ahead and get 1/3 of 31 5/10, which is 10 5/10. And then I have to multiply that by 4 7/10. And I end up with 49 35/100. And that will be feet cubed. Now we have to figure out if we have to round this or not. It says to the nearest cubic foot. So that means to the ones place. I'm going to look here. This is the ones place. Now this 3 is going to let me know if that 9 is going to go up 1 or stay the same. So that's going to stay the same. It will be 49 feet cubed for the volume of this hexagonal pyramid. Part 3, got it.
To the nearest cubic foot, what is the volume of the regular hexagonal pyramid?
Remember, find the area of the base first and then substitute that into the formula for volume of a pyramid. The correct answer is B, 14 feet cubed. And this is how you go about getting that answer. You first find the area of the base. Remember, decompose into 6 equilateral triangles. So area of one triangle times 6, because that's how you find the area of a hexagon. And then you go ahead and substitute all of that information in. The base of the triangle, if you look here, the base of that triangle will be equal to 2. Because all of the side lengths, they're equal to 2 for that hexagon. And then the height of that triangle will be equal to 1 7/10. And if you multiply all of this together, you would get 10 2/10. That will be the area of the base. Then you have to use that information and substitute it into the volume formula. So 10 2/10 is the area of the base. Now H, the height of the pyramid, if we look here, you go from the very top straight to the bottom, that will be 4 feet. So that's the height of the pyramid. Now we're going to multiply all of that. It doesn't matter how you multiply it. Once you do, you end up with 13 6/10. But we have to round to the ones place, and we end up with 14 feet cubed.